Dear students, I welcome you all for the online learning for the course Warehousing Automation. In the process of learning the course, the first unit, this is the last presentation pertaining to the first unit. That is, there are totally 10 chapters are there, and in this 8th chapter was divided into 2, and now 10th chapter is also divided into 2. So let me call this layout as the last chapter, that is 12th chapter. So with this particular topic, we are completely closing the learning part for the case of unit 1. So now we'll get into the layouts topic. So a warehouse layout refers to the physical arrangement of a warehouse storage and operational areas including placement, aisles, racks, shelves, equipment and flow of goods and people. It aims to optimize space utilization, improve operational efficiency, enhance safety and reduce cost. So before we get into the discussions with respect to warehouse layout, we'll just go for a very simple case, you have got a vacant site, you wanted to construct your home. Will we go for a design? We'll just go for a design. We'll go for a layout first before getting into the architectural concepts. We'll just go for a layout in which we'll come with a basic preamble. That do not mean that we design the layout. We'll give the input to the drafts person or to the engineer, civil engineer, then they will come out with the plan. So what is our requirement? We'll give our requirement like this. So we wanted to carpet area, we wanted to have a car parking, or what is the nature of plan, that is 1 BHK or 2 BHK, however the way we want it, with a puja room, or you wanted to have a common restrooms or something attached. So all sorts of inputs will be given from the user end, that is the one who owns the thing will give away. So similarly, when you wanted to go with a warehouse concept, as an engineer, it is our duty to give away the layout. So based on this, civil engineers will be able to design as well as they will be able to construct the thing. So what are the things should we consider here? Like the way in case of a home where we go for bedrooms, number of bedrooms, restrooms, carpet area, all such things will be decided by the end user. Similarly here we need to consider aisles. What is the definition for aisles and other things? We'll discuss in the upcoming slides. So racks, what type of racks we wanted to have, what is the size, what is the dimensions of them, shelves, what sort of equipments are we going to use, what is the flow direction, everything. Okay, with all these inputs, civil engineer will be in a position to go ahead with the construction of the warehouse. Now what all are the objectives? Considering what aims and what objectives will be designed is, the first foremost requirement is space utilization. We are going to utilize the space not with respect to area, with respect to volume. We'll be deciding upon the volume, number one. And number two, we should design in such a way that with minimum reach, with minimum distance, we are able to accomplish the tasks of picking and packing. So that's how we should think upon. Then safety, of course, this is the prime thing where safety is not having a holiday, as the saying goes by. So we should ensure that the layout is safer enough for human as well as for the products as well as for the equipments what we use. And finally, we should reduce the cost. Cost here means it is with respect to operational cost, it is with respect to energy cost. Even that is also to be considered, because proper sunlight has to be utilized. So lot many things govern here. Now how to go ahead with, what all are the ways and means are there, what all are the terminologies are there, we'll discuss one by one. Now first, in a home we have got, say, something like a hall, we have got some bedrooms or kitchen or puja room, something like that. In a warehouse we have got these areas. The first, receiving area. So receiving area is the one which is going to accept the part. It is a separate area where goods are going to be unloaded from the trucks. This is what a main interesting point is. Now when you have a truck, we knew an average height of the truck will be, say, from 0.5 to 1 meters of height. So now what is the thing is, we should have a facility where the truck should come partially inside the warehouse. That is how we are supposed to design. That is the input what we are supposed to give to the engineer, civil engineer. So they will be in a position to plan such a way. Then the other cases, some cases where the truck might be completely closed container like thing. So if it is container like thing, so how it will be dealt off, how the material handling system goes in, or if it is an open container, even we should give provision for both these cases. So receiving area, so receiving area should be adjacent somewhere at the entrance or exit of a nearby roadside. So that has to be thought of, not somewhere inside where material loading and unloading is going to be tedious. So that has to be thought of. And inspection area should be planned adjacent to the receiving area. Why? Because what are the products we receive, those things has to be inspected. So that is the first concept which we should know. Then the second, storage area. So it is very obvious that you get the products, the sample is being inspected, and upon inspection we are supposed to store somewhere. Yes, that is going to be mandatory part. Where do we store? So the storage area should be near to it, not far away. So it is supposed to be near to the area. So that has to be taken care. So storage area should be as near to the receiving area. Then next, order preparation and picking area. So this is the one. The moment you receive the order from an e-commerce platform, immediately the product has to be identified, it has to be picked and packed for further delivery. So again, here what is going to be the mode of delivery? Some cases that also might be by means of a truck. So that should be thought of. So here receiving area has to be well planned, storage area has to be planned in such a way that you are keeping it somewhere nearby, as well as order and preparation area also should be in the nearby vicinity. Next, shipping area. So once it is packed means somewhere we should preserve. See, always we will not be shipping. Say, for example, we work from morning 6 to night 10, let us assume. So after certain number of quantity gets accumulated, then only we start to ship. Not at the moment you receive one order, immediately pack it and send by means of a truck. No, it is not going to be profitable. So therefore we wait for a while where certain appreciable number of quantity is being gathered. So once a minimum quantity has been gathered, then we go for shipping. So till then, where do we preserve the product? Why? Because it is not supposed to be kept in an episode way, not something like piling, because products gets damaged. So it has to be nicely arranged, properly arranged, it has to be accounted, it has to be traceable. So considering all these activities, we should identify a proper shipping area. Then the next, office area. Obviously administrative tasks are going to be there, documentation parts, some documentation activities are there. So for that we are supposed to allocate some area. Now, what all are the factors governing this layout? The first is building's floor plan. This is very important. Why should we worry about the floor planners? See, all the cases, warehouses are not constructed. I stress upon the statement, it is not constructed right from scratch. All the cases. Some cases we rent the building. Some cases, some existing building will be purchased. So there are three conditions are there. First condition where we consider everything right from beginning, where we identify the land. From then when we construct means yes, layout is 100% sure it is going to be a successful one. On the second case, we might rent out. Some sort of rental buildings will be there for a particular tenure, not for lifetime, for a particular tenure, say for some 5 years or so. So we are supposed to modify the warehouse such a way that we should not do some sort of permanent modification. Why? Because it's a rented building perhaps. So we should take care of that particular condition. Then coming for the third aspect, it might be our own building. There still it's not a new one, that is not right from scratch. Some building we are modifying for our application. So plan has to be studied thoroughly. Building plan. See, in the earlier case when you saw the photographs of several warehouses, one thing you can understand, the central portion will not have any pillars. Inside the warehouses, pillars will not be there. Why? Because that's going to be an hindrance for the physical process automation. So that is how it has to be thought of. If it is there, then some other activity should be considered. So three conditions we should know. Then second, inventory characteristics. This is another important part. what is the type of product we handle, size, weight and storage requirements. Why storage requirement means certain products might be perishable. They might be perishable. So some sort of air conditioning might be required. Some products will be hazardous in nature. So we should keep in such a way, such an area that proper ventilation should be there. So likewise for each and every product, certain requirements are there that might be government oriented taxonomies or regular requirement of the product. So immaterial to those things, we should be in a position to consider the requirement. Then operational needs. Here operational needs means what is the volume of incoming and outgoing goods. So it might be in terms of a few numbers are tens or hundreds or even some cases are tons. So that we should know. So product which are very bulkier and heavy are not supposed to be taken to the corner of the activity. So that has to be thought of. Some cases volume may not be a big issue, but quantity might be a big issue. Okay. So all these things has to be thought of. And other thing is the frequency of order picking. So once in a while if you get means obviously that should not be positioned first. That has to be positioned somewhere. Then workflow. We should consider the workflow. How easy whether the product is handled or how difficult the process is to transport. So such things has to be considered. So obviously experience plays a very crucial role in this regard. Safety regulations. So safety is one particular aspect which you cannot deny or you are not supposed to deny at any point of time. So equipment safety comes first. Personal safety also is prioritized. So safety by all means. So layout has to be in such a way that safety should be there. So now here one mandatory requirement when you see is the first mandatory requirement is we should have fire extinguishers at all point of time. It do not mean that it is something which is going to be a flammable material, not with respect to the nature of the product. It is a basic need that warehouses should be thoroughly should have this safety features. So some sort of fire safety should be there, electrical safety should be thought of, everything should be thought of. Then equipment utilization. So obviously effective utilization by all means 360 degrees of things should be considered. Now, design part. How to start with the activity. Now you have been given with the task to with an existing building or whatever may be the scenario. If you have been asked to start with the layout of it's just a mere layout. You are going to propose your ideas. That's what here it means. So how to go ahead is the industrial standard is like this. So here you can see a small wooden plank which has been maybe piled up together in such a way that it has been nailed nicely, where you can see hollow there is a portion on all the sides. So it's something like a small platform. Okay, so this is called as a pallet. This particular unit is called as a pallet. Usually it is made out of wood. So what is the reason for the gap is there will be forklifters will be there. So forklifters come inside, the arms, the forks of the forklifter will go inside and it will just like that, it will lift the pallet. Okay, above the pallet we can go ahead with it. So this is one simple scenario. So the first rule of thumb is any width of the product what you plan in the receiving area in such a way that it should accommodate at least one pallet. Okay, so the pallet size is like this, 1 meter by 1.4 meter is the standard size. So unit load. So this is how we start. It is supposed to be such a way that a pallet of size 1 meter wide, 1.4 meter breadth as well as thickness of 300 millimeters should be loadable. It should be unloadable. Either cases it has to be thought of. Okay, they are the one which is standardized across the globe. Any industry you go ahead with across the globe, this is how it is going to be. Not only with respect to globe, even with respect to shipways. You have got a container, within the container this forklifter, entire forklifter itself will move inside and that will be able to handle the parts. So that's how the design is all about. So now we should go with one simple understanding that what is the pallet number, how many pallet numbers you will be able to handle at a time. Okay, how many times, so that is what n. Okay, For how many pallets you need to have a labor, or a labor will be able to handle number of pallets per hour with respect to some time. So this minimum data is highly essential. Now we come for the term. See, when you spell up, it might look like A-I-S-L-E, but the pronunciation is just isle. Okay. So S is going to be silent. The way, how do we pronounce island? Okay. Island where S is silent, right? So likewise here also, it is not, S has to be considered to be silent. So therefore we call it as isle. So what is the isle is? It is the pathway. It is the pathway or the walkway between storage racks or shelves. Okay. So now let me put a pause to the definition. I'll come back to an example. See, you have got two successive racks. You go to library, you have got some racks together where racks are having different shelves and different types of books. That is natures of book based on the subjects. It has been neatly and nicely it has been organized. Think of when you have two racks within maybe the either ends of the racks has been nicely made to stick against each other, will not be able to access in between. So we'll have some sort of gap, right? So you've got rack 1, rack 2 and there is a gap. What is the nature of gap? How much gap should we give means we should give at least we should give that two people are able to walk adjacent. When two people are like this, they should be in a position to move freely. That is all. If you give gap as for one person, only one will be able to access and the second one will not be able to get in. So movement is going to be drawback. Okay, this is called as aisle. This is called as aisle. The gap what you give, okay, with the gap between two successive racks is going to be called as aisle. Now, why it is a very crucial part? It is always crucial. Why? Because this particular gap is going to facilitate future movement. Today you might be in a manual case, but definitely with respect to time, we will be automizing it. When you automating it, what will happen? Some modern material handling system will be maneuvering inside. So we should plan such things. So I think you'll be in a position to recall with respect to AGV as well as AMR. The drawback with AGV is the turning radius. So it will not be able to take up a steady sharp cut. Perhaps AMR will be able to do it. So we should have a proper provision for that. As well, please recall the tortoise shuttles, what we learned earlier, where tortoise shuttles will be having rack on the track on the either racks. So this aisle will be the gap, the width of the aisle will be the width of the shuttle. So therefore that is going to smoothly traverse front and back in within which. So this is where the efficiency comes into picture. So aisle has to be considered. So that is the first point. The next. This is how the aisle is looks like. Okay. So you have got racks. So now here you can see in this particular case there is no aisle. That means that even a man also cannot go within the gap. Perhaps you see for the other case, yes, sufficient amount of gap is there. So here man can go. Maybe in future we can think of some other automating case. So here this gap, but here there is no gap given. So this is how the layout goes on. So you can plan in such a way that the gap should be appreciably narrower. It should not be wide enough because space utilization is going to be a big crucial task. If you try to minimize, again, efficiency will be good. That is, utilization efficiency will be good. But how about manual movement or material movement? So it should be optimum enough. That's where optimization plays a very crucial role. Now, will we go for a rack or will we go for a stack? Okay. We'll just go for a simple example. So this is racking, where you have got nice structures, heavy structures which can withstand sufficient goods. So pallets are there. So I hope you'll be able to see the pallets. So pallets are there. So nicely the product is kept above the pallet. So it is easy for us to lift everything. This is racking. Racking means you will have a special rack, okay, which will have shelves. So on each shelf we can use pallet, and above the pallet we can nicely pack and we can provision it. Stacking, it's an age-old practice but do not require any sort of investment. So this is stacking. Same pallet case is there. Above the pallet we have got material, everything is there, but just blindly we keep one above the other. So now what will happen? This load will obviously be on the first and the second product. So it is going to get damaged, right? But only for few minutes or so it is going to be of that nature, means still it is not accepted. Okay. So stacking was earlier, it was considered, but now stacking no. But without stacking, how to go on means like in a very proper way, in a very rigid way, it can be stacked upon, but not like this in a very haphazard case. The next, lane depth. Lane depth is nothing but the length, how long you are going to keep your lanes. So it is obviously, it is going to be, theoretically speaking, obviously it has to be length of the godown, but that is warehouse, but it is not always suggested. Why? Because safety concern. Okay, it's going to be safety concern. Then the other important thing is, once you keep somewhere long, obviously aisle will be minimum, that is with respect to the length of the lane, and the width what we provide, the gap, the aisle will be minimum. So that is not a professional thing which can be appreciated. Okay, it should have some sort of correlation. So therefore the minimum requirement is like this: a forklift should go inside. So this is what the minimum requirement, as we discussed in the library case, where two people adjacent way, that is the minimum requirement. So similarly here forklifter should go, it should get there, as well as it should keep, as well as it should retrieve the product. Okay, so let me give a another simple example. When you plan for some layout, okay, it should be considered that the maximum product which can occupy maximum space. So considering that, we'll be designing. Okay, that is the kickstart point, but over a period of time we try to minimize based on the advanced system what we hop in. Now this is the graphical part what we do. Okay, so have a clear understanding. The overall size, the length as well as width is nicely, it is grid, that is uniformly it is spaced, and array is formed. Then the dark lines what you see is, these all are the racks. So the racks are planned. So now this is going to be the aisle, this is called as the aisle portion. So this portion should be appreciably strong, that initially forklifter should go, maybe gradually we can think upon. So this is single layout, where that is you got only access only on either sides. So in between you will not be able to access. So this is how it goes on. So when you think of the second, even you can cluster, but this clustering of racks will be based on the product width. So product will be deciding. However, we should try to stick to the aisle minimum requirement of the aisle. Okay, because this half width of the product will be able to access through this aisle. So this has to be considered. Okay, so this is another case. So unoccupied, that is whenever you take up the products. So first case, I will just go with this example. The first case where initially backside will not be able to access, only front will be able to access. So there are 4 products are there. The moment one is over, so the layout has to be appreciably updated, that the 4th one should be shown as vacant. So obviously it is only possible by means of software. So likewise we should think of. Now in this case it is an independent rack, so therefore we remove that particular rack. But think like this. So this is single deep. Now 2 deep. So 4 positions are there. One position you have removed the product, but still for this particular product this rack cannot be removed. It has to be there only. So likewise even racks can be made empty. So similarly for 3 deep and 4 deep. So when you see the difference between 4 deep and 1 deep is only that direction. Okay. So likewise we can come out with some sort of creative thinking. Even I will show you other designs, creative designs also. Now, what is the role of labor? Earlier point we discussed with respect to design part. Okay, design means we took the entire floor space, we made small arrays, a grid pattern was made. So based on that we just worked. Now from a labor perspective, once a product comes and been located in the receiving area, now it is duty of a labor to bring that particular part to the rack. Now let us think in one simple perspective. We need to pay for the forklifter operator as well as for the forklift with respect to time or with respect to number of products they just loaded or unloaded, either case. Okay. Now, this money should be minimum or maximum. When we have this particular question, it is very obvious that it is supposed to be minimum. This is what we just go ahead with. Whether they load or unload, that money what we pay should be minimum. That means the time what they take for loading and unloading should also be minimum. Okay. So that is going to be the objective. How to design layouts to minimize this. So that is the second constraint. So first was space constraint. Second thing is minimum material handling movement. That might be man or that might be machine. Now, deadheading. This is another important term. Whenever you come across with respect to layout, deadheading is going to be there. Deadheading means non-value added movements are going to be called as deadheading. Okay, deadheading should always be minimized. Non-value adding activity. Now, there is one particular product which has to be lifted. Now the forklift is somewhere else. It need to travel for say some 200 meters to lift that particular product. While going, it is going empty. Okay, when going, it is going to be empty. So that is going to be called as dead ending. Whether it does the job, that is, he loads or unloads, but still the vehicle is going to be empty. It is going to move for the case of empty. So that is called as dead ending, where warehouse dead ending is always, it is prohibited. So how to utilize? That's where layout design comes into picture. Then second, single cycle. Single cycle means it does only one task, but to and fro movement will be there, to will be there and fro will be there. So in any one movement, if it is going to be dead heading, so that is called as single cycle. Only one other thing will be, definitely it is going to be empty. Now we'll see the layout. So see the layout. So from the receiving point, that is this particular point, the forklifter from here, it goes to, let me call this point as A point. So from this, let me call this as home point, H point. So black color means he is going to load. Okay, he is going to load to the A point. So from here, H point, he goes directly to the A point, loads the component at A point and is going to come with the empty cart. The forklifter is going to be empty. So now this is called as single cycle. Single cycle, only one activity will be there. Second activity will not be involved. Second activity do not be involved. Now similarly for B position. So this is going to be the second position. So same thing, only one activity will be and value adding and the second will be a non-value adding. This is called as single cycle. So likewise we can go ahead with. But this is not always appreciated because only 50% is profitable and the rest 50% is dead heading and non-value added activity. So that is where a warehousing engineer comes into picture, where he automates and he ensures that that 50% of backlash is eliminated. Now, obviously we should go for dual cycle. That means either cycle it is supposed to load and unload. So it might be loading or it might be retrieval. However the case, we wanted to have both these activities. So to as well as fro should always be a proper utilized one. So now a question might be arising. How do I do this task? This is very important. So we should assign the trip. Trip means to and fro should be properly done. So what tool will we be using? That's going to be the haunting question inside view. Okay, this is how it has to be planned. So as discussed earlier, this is the first point, that is home point. So home point is there. So from the home point, it directly goes to the A point. Okay, then from there it comes to B point, picks up something from B and he comes. So this trip is planned, but still it is not 100% effective because there is a red portion, idle portion is there, but still it is not empty partially. So it is better with respect to the earlier solution. Similarly, let us come for the next. So let me call this as X and this as Y. So from H point, it comes, unloads something at X and then goes to Y, then picks up something and comes back to H point. Okay. So this is how dual cycle works when compared to single cycle, where single cycle abruptly 50% is a dead heading. whereas when we come for dual cycle, it is not so. But not 50%, the rest 50% has been minimized up to a certain extent. Now, still we can improvise. How means this has to be considered as an assignment problem, a part of operations research. So assignment problem is a part of operations research where we can plan in a very wise case that the layout as well as assignment should be in a very coherent way, so that even that 50% of the dead handing can be minimized to a greater extent. So now we'll see how. So from the receiving end, okay, the product is received, it goes to A point, keeps something else and takes up something, or even in an empty cart it might go to the shipping point. So it goes to the shipping point. So after shipping, so it comes, unload something and it goes on. So the aim here is assignment based tasks, and the aim is minimizing the dead heading. So that dead heading is always going to be an evergreen as well as interesting task. Okay, now different types of interesting layouts. So this is another assignment problem based. That means initially it will go in the raster scan pattern. So raster scan means like this, front, so it will come back again to, again it will go like this. So this is called as raster scan. So on the due course it will add a tortoise shuttle or something like that. So four-way movements will be ensured. So this is one interesting part. And this is not the top ceiling or something. Still, it has got very good research potential also. And second thing, like this, okay, triangular based, maybe by means of AGVs. So when you go ahead with AGVs, one AGV will be able to take up one particular zone, one particular area. So even that can be thought of. Now, cross assign. So first point was with respect to agile, that is aisle. Then the next was with respect to labor, that is material handling, and the third is different types of layouts, that is configurations to facilitate movement in between. In between, how do we go ahead with? So this is how the aisle is considered. So let us consider from this particular point, we should come for the next point B. Okay, earlier designs what we saw was it was all along the way like this. So it should come. So the distance is high. When we optimize, what happens is the maneuvering of the forklift can happen somewhere in between. Even like this, it can go ahead with. So this aisle configuration should be very stringent enough, so that we should have a proper radius to make the turn. Okay, this is cross aisle pattern. And next is the another configuration, parallel aisle or perpendicular aisle, or some cases mixed aisle. So what the research says is 20% we can save the distance like this. So it is a combination of parallel as well as perpendicular aspects. So here it is perpendicular, but here it is parallel. So now it is very easy for us to maneuver in between. So likewise, all sorts of creativity can be penned in here, and using an assignment problem, layouts can be optimized to a greater extent. And now this is the final drawing. This is the final drawing or the final layout of a warehouse. So here you can see it has got a space for receiving, then it has got space for all the activities. So at the moment when you see the layout, you can tell yes, there are good provisions for the aisles. Aisles are very good enough, but here in this case it is a dead ending. So obviously a U-turn has to be taken by the material handling equipment, and here it is, they can go on the raster pan mechanism. So likewise you can have the interpretation here. Okay, so this is how systems will be designed, and here it is of open end. So in the open end case, it is very easy for us to access. That means bulkier products and frequently used products are positioned here. The products which are least utilized are being made available here. So likewise we can draw conclusions from the layout. So to summarize the presentation, so we discussed about layouts. So layouts are very essential for the case of not only with respect to space utilization, also with respect to loading and unloading of parts. So IL plays a very crucial role in this regard. And IL configurations, we saw about different types of configurations, different types of movements, how assignment problem plays a very crucial role inside a layout of a warehouse we discussed. So to summarize the entire unit 1, so unit 1, 4 islands, let me put like this, 4 major islands. The first was warehousing processes and the challenges, followed by the important aspects of automation inside warehouse, what all are the benefits we go ahead with. And the third was physical process automation, that means material handling systems was the third element, and the fourth element was with respect to design aspects of a layout. So these all are the 4 crucial takeaways from the first unit. I hope learners, you would have got a very good knowledge, you would have got enriched with sufficient knowledge with respect to warehousing and automation and the scope, not only with respect to career, with respect to research. There are plenty of scopes even till date. There are several opportunities are there to develop, to grow, as well as several softwares are available. Even in our college, we have got several softwares, especially in this regard, say by name Visual Components, and there are many more things with respect to PLM. There are many more things are there. So I hope with this contents we finish unit 1. Any doubts, please note down. We can discuss in the offline classes, and even you need not to wait till the offline classes. Please come and meet me in person, or even I can be contacted over phone. So with this we conclude unit 1. Thank you all.